And as Stacy mentioned, we are trying to make use of the data that HCRC is making available to us. But first apology is that actually the data I'm going to show you doesn't come from the HathiTrust collection today, but I'm going to explain to you how we hope to use it and talk about some of the problems of scaling up to that size of a collection. Second apology, I was forced at the last moment to export my slides from Keynote to PowerPoint, so some of the transitions and things didn't come through, and especially there's supposed to be a background on this, which would make it more readable. But the goal for me today is to explain to you where I think we're going with this, which is beyond being able to generate nice pictures of networks of terms and so on, to trying to do some interesting analysis of what these data are telling us and hoping to understand some of the models better that we're working with. So just very quickly oh, wrong machine. I guess I'm on this one. I just want to acknowledge a few people who've been instrumental in the project, and particularly Jamie Murdoch, bottom right there, who will be around the room later this morning and is very equipped to answer any technical questions, and Robert Rose, who doesn't look like the robot, but he is a robot, and he's just shy around cameras, I think. And of course, there are a number of other people in the room who've been very supportive and helpful and acknowledged the funding we've had from IU and the National Endowment for the Humanities. Now, what is this graph in the background? Well, what we're looking at here is a network of terms from two different encyclopedias. I've been working for a long time with the Stanford Encyclopedia of Philosophy, which is an online dynamic encyclopedia, obviously of philosophy, that's been in production for about 17, 18 years now. And one of the questions we might have as philosophers is, how does the coverage of this encyclopedia differ from the coverage of another encyclopedia? So there happens to be another open access Encyclopedia of Philosophy online, the Internet Encyclopedia of Philosophy. And the question is, can we do any analysis and can we use visualizations to help us understand the difference between these two? I'm going to come back to examples such as this one, not this one exactly, but if you take Kant and you lay out the terms on a semantically neutral background between the two encyclopedias, I can explain later how that happens, and then you see a cluster of names in the top left there, you see a cluster of concepts in the bottom right here. This is using a particular model developed here at IU by Mike Jones, called the Beagle Composite model that, again, I won't have time to explain in detail. But you can see that the strongest terms for the SEP, colored in red, and the strongest terms, most similar terms for the IEP, according to this model, colored in blue, show some differences. And in particular, anybody who knows anything about the history of philosophy will recognize that for the Stanford Encyclopedia, there's much more attention to early modern philosophy and contemporary analytic philosophy, at least at this level of analysis, this grain of analysis. Whereas for the Internet Encyclopedia of Philosophy, you're seeing names like Schopenhauer and Deleuze, which reflects a more continental European orientation down towards the bottom left of the diagram here. So these are the kinds of visualizations which we don't think are ends in themselves, but are spurs to help us think harder about the data that we're getting and what the models on those data are providing. So, what might philosophers do with millions of words? Well, before we get into the HathiTrust collection, how much are we looking at? Stanford Encyclopedia of Philosophy is 12 million words. The Internet Encyclopedia of Philosophy is 4 million words. And we've also been working with the Phil Papers database, which is a collection of about 480,000 bibliographic records, about half of which come with abstracts. So titles and abstracts together give you about 21 million words there. And of course, you might go, well, just read them all. You're philosophers. What else do you do? And if you work that out, that's something like 2,500 hours if you can read at 250 words a minute, roughly a page a minute, which I've converted into the faculty familiar one sabbatical year. It's working 50 hours a week. So you're going to be forced into reading them selectively, but how do you do that? And if you add in the 2.6 million volumes that we heard about yesterday from the HathiTrust public domain collection, we're now into the range of about 230 to 250 billion words. That's roughly what I calculate on the basis of this. So as Stacy mentioned, we have a Digging into Data grant here, myself and Katie Berner here at IU and some partners in the UK. And our dream is that we ought to be able to mine all of these data from the HathiTrust collection and actually map philosophy onto various backgrounds, such as one thing that Katie is very interested in and I as a philosopher of science am very interested in, such as a map of science. So this is just a mock-up, but our idea is that we can perhaps identify places in science by looking at the collection where philosophical discussion and debate is especially prominent. So you might think that there's more philosophy going on, let's say, in comparative psychology, which is an area I happen to be interested in, than in, let's say, geology, right? There'll be some, but there might be more in certain areas that prove to be more controversial than others. And our goal is that if we can identify these areas and find specific texts that link to that, so this is Lloyd Morgan's 1894 Introduction to Comparative Psychology, then we can dig into those texts in more detail, and this is really the UK side of the project, and actually get into the argument structure and provide a very useful tool that will allow philosophers and historians of science to explore the HathiTrust collection and find out very specific things about the text that they're interested in. And as we heard yesterday too from Beth, the collection is very heavily oriented towards the 19th century, so we've picked 19th, early 20th century because that's what's in the public domain area as our initial focus. Obviously, we can't deal with all 2.6 million volumes right now, so we're trying to pick smaller subsets of that to run analyses on. Now, of course, the problem is, where do you find anything in this? And you can go and search in the HathiTrust's own interface, and you might search for some terms that you think are related to the philosophical arguments that go on in the field of comparative psychology. You know, how similar are animals to humans? So words like anthropomorphism and parsimony come up there. But you'll see immediately from these results that there's a whole bunch of other stuff that's got nothing to do with comparative psychology coming up. And of course, information retrieval is a long-standing problem in this area. We're hoping to add a new twist to it, and to emphasize again, our goal is in the end not the information retrieval per se, but then what we can do to analyze the data that we get in this way. We do have some other sources. So I mentioned the Internet Encyclopedia of Philosophy, the Stanford Encyclopedia of Philosophy, and our own MPhil papers. So if you search for these two terms in the Internet Encyclopedia of Philosophy, they're using Google custom search on their site, you find just two returns, animal minds and moral development, which puts us in a rather different space than what we got from HathiTrust. If we search in the Stanford Encyclopedia of Philosophy, we find animal cognition and animal consciousness come up top, and then we get down into some other things. William of Ockham at the bottom, very obvious for parsimony. And if we look at the Phil papers, again, we find a paper about comparative psychology at the top, one about anthropomorphism in science more generally in the second, and actually a piece by me on anthropomorphism third there, which is also in the animal cognition domain. So you can see philosophers are talking about these issues in a rather different space than that collection would suggest. And our question is, how can we match up those spaces? So we've been developing tools here. I have this fairly long-running now INFO project, which stands for Indiana Philosophy Ontology. For those of you who are computer scientists in the room or know something about ontologies, we have a rather loose notion of ontology, which will get us in trouble in certain places, but I'm perfectly happy to defend it. We think ontologies are for people too, not just for machines. But as an extension from that, we've been moving into what we're now calling the infosemantics project, where we're making much more general use of models, not just sort of structured representations. And we've developed a sort of test interface, which isn't, if all of you hit it right now, would bring our server to its knees. That's one of our problems right now. But we can actually go in and select various corpuses. We can select various models. We can select various terms. And from that, we can generate lists of terms that are judged most similar to the head terms that we chose for that particular model. So here we're looking at the output for two encyclopedias, the Stanford Encyclopedia with the red header on the left and the Internet Encyclopedia with the blue header on the right. One model that I chose in this case, again, Beagle, I'm just picking for the sake of illustration. It's not the only one we're interested in. And then these terms parsimony and anthropomorphism. And we can see what the list of terms are. And if this were a live demo, and I saw enough yesterday to know not to do live demos in this room, if you roll over the terms here, then it highlights the corresponding terms in the other list. So very quickly, you can get a feel for how much of this data is similar across the different models. We also have our original Indiana Philosophy Ontology project, and there we've done some human-assisted data mining to build a structured representation to get related terms to animal cognition, and that's information which can also be useful. I'm not going to have time to say very much about it, but it helps us understand the space in which philosophers, at least, are arguing about these issues. And just, we have an API, so if you click on the API, this interface should be robust, so anybody can go to info.cogs.indiana.edu, and there's a machine-readable version of all of these data just available on our API. And we're also exposing some of the statistical analysis that we've done of the Stanford Encyclopedia through that particular API. Our goal is to actually extend this to allow you to download similar data for all of the different sources that we're modeling. Now, if we go back and look again, here I've run the one model. Again, I'm just going to stick with that today. And 4 different head terms across the 2 encyclopedias. So I have Aristotle, metaphysics, epistemology, and ethics. Again, I might have a question. This is sort of neat. I can roll around and see which terms appear wherever. I happen to highlight criticism here as the next to last on epistemology. That's the only list of the top, I think I did, let's see, 12 there, where that shows up. I guess epistemology contains a lot of criticism. But using the Beagle model and going deeper into this, we might be able to find structures. So this is just using Cathy Bernard's Network Workbench project, a way of looking at those terms and their associations in the 2 encyclopedias to try to see how much overlap there might be between the 2 encyclopedias. So we have Aristotle, metaphysics, ethics, and epistemology as the 4 head terms. The red lines are ones where that appeared only in a Stanford Encyclopedia list. The blue lines are where it appeared only in an Internet Encyclopedia list. The purple lines are where it appeared on both of the lists. And the width of the line indicates the 0.7 or greater cosine similarity value. So you can see there's a fair amount of clustering around metaphysics in terms of overlap, a bit less around Aristotle, even less around epistemology. And that provides some interesting insight into the possible structure. But again, I don't regard the visualization here as the endpoint. We want to go further with the analysis. So just, I'm going to give you an example here from Turing that I happened to work up earlier this year for another conference. So with Turing, we might wonder how the 2 encyclopedias differ. And we use a tool here called Word to Word, also developed at IU by Brent Kiewit-Keiler, in which we are looking at the terms associated with Turing in the 2 encyclopedias and the degree of similarity between each of the secondary degree of similarity between each of those terms. And here I've laid out around about 125 of the most similar terms to Turing from the 2 encyclopedias. I've laid it out using a multi-dimensional scaling algorithm to show you a neutral semantic space between the 2. And then I've colorized the strongest ones for each of the 2 encyclopedias by red, as always, for the Stanford Encyclopedia and blue for the Internet Encyclopedia. And again, you can see a nice, clear segregation in this display. And what's interesting is you notice that the Stanford Encyclopedia is stronger around issues concerning formal computability theory, and the Internet Encyclopedia's stronger links are around things that have to do with Turing's discussion of whether machines are good models for human cognition and consciousness. Right? Both encyclopedias cover both topics, but they weight them rather differently, and we can begin to see this with this kind of analysis. And if I overlay the Phil Papers data on this, so now I'm looking at the 480,000 bibliographic records, I think this is interesting because you see something that looks a bit like a common structure between the 2 where they overlapped on the previous one. There was, you know, the SEP and the IEP picked out some rather similar things. And this brings up issues for me about what scale we ought to be doing these analyses. I think the temptation when we have, you know, 250 billion words available to us is just analyze them all. Of course, we're up against practical limits for that, but context matters, and finding the right grain here for the analysis is an important part of this. And our idea is that we need to run different models at different scales with different subsets and compare their outputs to try to understand what the models are telling us and what the data is telling us. I'm just going to skip very quickly through this in the interest of time, but we can look at philosophers. Here I took Kant again, and I just used the R statistical package to lay out similarity values for Kant between the two encyclopedias. And you can see there's a correlation there, but there's also a lot of noise in that correlation. And the question is, can we do a closer analysis of that? So again, what we're looking at here is position. So the number one term happens to be the same on both lists because Kant is self-correlated with degree 1. So we're plotting position on the IEP list against position on the SEP list, and that's the scatter that you get. If we limit it to the first 500 terms instead of the first 10,000 terms, you can still see there's a trend, but there's a bunch of outliers. If I just go back, overall, the degree of similarity is not showing up here because of the switchover, but it's about 0.73 if you do Spearman rank correlation on this graph. So pretty good agreement over that many terms. But what if we do fewer? And this is going to mess up, I think. Well, let's see. This is part of the last minute change. Oh, no, there we go. OK, so actually, it turns out to be interesting that the rank correlation between these two lists varies as a function of how many terms you take into the analysis. And I can't tell you whether this double dip phenomenon here is an artifact at the moment, and neither can he. But we have a high degree, at least, of correlation on one way of looking at it early in the list, then some divergence sort of within the first 10 to 20 terms, then some convergence again in terms of how closely the two encyclopedias match each other, then some further divergence, and then a long tail of convergence as we bring more and more terms into the analysis. And so if we want to understand how these two encyclopedias differ, we can't just say, here's 10,000 terms, look at the correlation between them, right? We need some tools for understanding the structure of those correlations, the structure of that data, of those data, and that's one of the things we're very interested in doing. And furthermore, not just sticking to one head term. What about all of the other terms associated with Kant? Can we find bigger structure in such a matrix of correlations? All right, so we've already mentioned the digging by debating, this joint project with my own group, with Caddy Berner here at IU, and with various UK partners, and all of these words that we're looking at. And our aim is to bring then as much of these data as practically possible into the fold, and that is going to raise enormous scaling challenges. As I mentioned, context sensitivity is going to be important. More data is not always better, right? So we need to actually run lots of models here on lots of subsets of the data to try to figure out where we get the most bang for our buck, so to speak. And we need ways of comparing these models at multiple scales. And that turns out to be something that has the statisticians here on campus scratching their heads as much as us. And we're trying to understand how to deal with this. All right. We've also realized that in order to do this well, in order to run all these experiments with different models on different data sets, we are going to need a very robust architecture, not just for running the experiments, but for storing the output of those experiments and for being able to replicate those experiments. So this is just a sketch right now of an architecture for that in which we've modularized various aspects of the corpus preparation, the model running, and then the analysis afterwards. And we are trying to build this in a way that will make it usable for other projects, scalable, possibly runnable on a virtual machine through HTRC. These are all directions in which we're actively working with Beth and others here to try to do that. All right, so that came out terribly because of the export, but we're also working, we have a second grant from NEH and the DFG in Germany to link our data to the linked open data cloud, and that has all kinds of interesting problems with it. But I think there are numerous research avenues. the model comparison I've been talking about, how we manage to switch context and how we can use our understanding of what the models are telling us to help get at things that people want to get out of these data. What it is to have domain expertise. So some people think about Kant and Hegel and other people think about Kant and Hume. And how do we understand that different sources are going to emphasize different things accordingly. As I've mentioned, corpus comparisons, we can look at the state of the profession, and we can do that historically. All right, with all of these HathiTrust volumes, we can look at how certain kinds of debates changed over time. So with that, I think I've left myself about 5 to 10 minutes for questions, so I'm happy to take them. Thank you. Yeah.
So with the encyclopedias of philosophy, you have fairly small corpuses that you're comparing. And I imagine that when you're doing this much larger, corpus, you can get much more sophisticated with what you do. But I couldn't understand from your presentation what you're trying to do beyond what you've already done with those encyclopedias of philosophy. Mm-hmm.
So what we're trying to do beyond with the encyclopedias is actually be able to get in and use the kinds of statistical analyses that we think we can provide to not just locate discussions of particular topics, so topic modeling could do that, but actually to get in and find places where scientists and philosophers are engaged in common debates. So we want to get more into the argumentative structure of the text. We want to use, I tended to focus, and this has been my bias, on content terms in philosophy, but we've also been looking at recently argumentative structure terms, so consequently, therefore, all of these words that people giving arguments use, and can we use the relations between those to help us isolate particular passages, pages from books, which are then ripe for the kind of detailed argumentative analysis that philosophers and historians of science care about, right? So I think this is an essential part of our project. Is we don't just want sort of the high-level abstract gloss on term similarity at a corpus level or even a book level. We want to use that as a way to get into the real structure of the text in a way that scholars of these texts want to make use of them. Okay. Good. Oh, yeah. Sorry.
How are you dealing with multiple languages in the corpus analysis for HathiTrust? Are you just going to use English language terms?
So the question is how we're going to deal with multiple languages, and the answer is I have lots of interest in doing that, but right now we are treating whatever corpus we have simply as a single language, whether it contains multiple language terms or not, right? So, so what's interesting, and I could show you this, is if you go into our the list tool that lets us see related terms, and you type German words such as Entwicklung into that, then the SEP will give you a whole bunch of other German terms that are associated with that. Why? Because the German discussion of development turns out to be, organismic development turns out to be very important for philosophical analysis of that concept. So there's lots of citations and things to German sources that give us kind of a little toehold into the German language there. If, as you broaden out, right, you would bring more terms, but they might still be isolated islands. And that's now we've got a really interesting question, is can we map perhaps the structure of what goes on in the German or French or whatever discussion of, let's say, comparative psychology to the structure of what goes on in the English language discussion of that. And there we actually, we think, but we don't have the funds or the resources to do this at the moment, but we think there might be something rather similar possible to what we're doing more generally to compare structures within a language, to now compare structures across language. And it also hooks up to our goals with the linked open data project, which is to try to map points in one database to points in another database, right? That's essentially what we're doing there. So you could think about doing that between models of different portions of the text and so on. But no, these are really important questions, and I would love to get further with it, and I'm happy to talk to people who have ideas about how to pursue that. So. All right, Good. Well, thank you very much.